Okay. So now for the solution. Hopefully you have worked on this and successfully come up with 51.4 milliliters.
First, we'll talk about
so what is our starting point?
The problem worked
Well, we
out
want to get to moles in the middle.
And then I'm going to ask you.
The way we can do that is we can take the volume of the solution times its molarity.
The next video in the series.
But first, let's get the volume into liters. So 35.7 milliliters.
Additional problem. Okay.
Using this conversion factor gives us 0.0357 liters.
And I mentioned in class, instead of going from
this solution,
grams of A
so then
moles of A, we're taking a value of A.
So this is a whole new line.
But because we also have a concentration, we can use that volume and that concentration to get to moles in the middle.
We're taking that value in liters.
And so then in the middle here,
and we're multiplying it by its concentration.
Moles of B, we use our stoichiometric coefficients.
Liters cancels out.
Just like we do in
and we're left with
stoichiometry problem.
The number of moles,
to get to moles
of sodium carbonate
thing in the reaction
available.
Generically, we're saying
then we take that number of moles and we use the stoichiometric coefficients from the balanced equation.
We use the concentration
2 moles of nitric acid for every 1 mole of sodium nitrate.
How much volume
that means that we
will be produced or used
double the number of nitric acid molecules.
All right. So
then we bring that number down.
Look at the example.
We multiply it by the inverse of its concentration.
And so we're given.
See, here's the concentration
of
0.15, and that's moles per liter.
Excuse me. We're asked to solve for.
But we want to get to volume, so we have to have moles on the bottom. Because we have moles here, so
and
moles
we're saying
on the bottom. So we use the inverse of the concentration.
It will react with this volume.
We take this number and divide by 0.15. And we get 0.0514 liters of this solution.
I will always give you a balanced
question asks for milliliters, so we do one more step and we convert.
You are required to know how to balance equations, but that'll be
some of you will have noticed
specifically
that
refers to balance.
Up here we multiplied by 10 to the negative third, and here we divided by 10 to the negative third.
So,
therefore, we could have skipped that step, and our answer would have been
But because I'm real big into conversion factors and canceling units out.
But what has always concerned me is if I tell you you can skip that now,
process is
at some point you'll skip it when you can't.
With his
so because
I guess I'll scroll back up.
Molarity, big M, is moles per liter.
But I really
best
want you to focus on
just getting into liters.
This part,
and then you know
titled solution
that that will not be a problem.
It really does focus on the crossing out. We got the little blue lines,
and I will see.
Where here we use the concentration in moles per liter. Again, not big M, because big M we don't see the units, right? This is moles per liter is symbolized with a big M. But if we were to use a big M here, we wouldn't see the moles per liter, and then liters wouldn't cancel out. So we get liters to cancel out. If we stopped right here, we would have how many moles of lead nitrate were used. But we don't want to stop right here. We use the stoichiometric coefficients to see if this many moles, the solution to this step, react in that balanced equation, then 2 moles of potassium chloride are made for every 1 mole of nitrate, lead nitrate. And so if we stopped right here, we would know moles of KCl, but still not what we're asked for. We're given a concentration of KCl, but see, notice here, the real concentration is moles per liter, but because we're focusing, I like to focus on conversion factors, or this is why I like to focus on conversion factors, we're actually using the inverse of the concentration, because now we need moles of KCl to cancel out, and we need volume to be left, and so it goes on top. And so the solution is 0.35 liters of KCl. So what I want to emphasize is that we're getting moles in the middle, and this step here, the coefficients, is the same regardless of how you get to moles in the middle. Lots of ways to get to moles in the middle. In this case, we're doing it starting with a volume and a concentration. Okay, I'm going to end the video here, and what I want you to do is work on this first practice problem, and then the next video will show the solution to this video, or to this question. Okay, thank you.